Yo, yo, yo. What's up? What's up? Welcome back. Today we're working on my operating system. It's an x86 operating system written in Rust. And I guess probably the best place to start is like a little bit of a demo. So when I type cargo run, I like build, compile my kernel, pop it open in QEMU, which is like a virtual machine. And we've been working on like mouse support. So here I'm like controlling the paddle with my mouse, which is like a USB mouse, which means we have like a USB subsystem starting to work that requires like PCI in order to talk to the device, like and a bunch of like other stuff going on to like get like the operating system booting and running. We also have a like web stack going on. So if I go to like the IP of the device, I can say like hello from the Streamlabs kernel. I can say like hello, and it will like send that data back to me, proving that we have like the Ethernet card working and like TCP and HTTP and stuff like that. Yeah, so that's kind of like where the thing is sitting right now. We have like a bunch of infrastructure for like logging, unit testing, etc. Like we're seeing logs here that are coming out of like the serial console, which QEMU is forwarding over to standard input output. And what we want to work on today is like kind of continuing the saga of mouse driver setup. So last stream we kind of got a mouse driver that worked enough that we could like pipe the cursor position over to our little game here, but then we left a lot like unfixed and unanswered. So I have like a list of things that I thought would be kind of good to get through today. Specifically, we found like there were some cases where we wanted to like construct a value and say, hey, when this finishes, let me know, but only once. And we don't have like a type for that, so I thought we should implement that, as well as like a similar type that says instead of like somebody sitting, maybe I'll pull open a paint window. There's like some driver, he's sitting over here, and he's got like he's like polling like the USB hardware. Maybe he's like mouse updates. And he's going to be sitting here and he's going to get like a list of updates. Doot, 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 doot. And over here, we might have like the cursor. And all we really care about is like the latest position. We might not care about every single update that comes in, right? So like in a similar way, we might want to have somebody that only takes the first one. We might also want somebody who only takes the last one. And so we have like a couple places where both of those concepts would be useful, so we want to like work on that. Then we have some places last stream where we had like these like queues of things that were being piped around, and it'd be kind of nicer if those were like abstracted away so that like consumers of the API didn't need to know about the internal details of like that we're using a one-shot queue for something. They just care like I want the thing. I don't care about like the queuing mechanism. And then like we have this problem here where the paddle updates like very slowly, and we can probably fix that because this is like using like a really slow clock to pull the position. We could fix that by using like USB interrupts. Yeah, so that's what I want to work on. Someone's talking to me in chat. What's up, dude? Have I ever thought about making one sender, multiple receiver channel? I mean, I think that there's probably going to be a time where that comes up. But I think that probably I would know. I would probably do like a pretty stupid implementation there. But yeah, we'll see. I don't think that it's like coming up right now or anything. Yeah. Okay, so let's just get into it with starting with like a one-shot future. So maybe we'll say one-shot future. Okay. So maybe like the context for this is in our like mouse driver and our USB system. We have this like concept of the USB system. He's kind of like running like an event loop essentially. He's like running over, he's basically like waiting for somebody to queue some work for him to do. I.e. like my mouse driver says like mouse. He says like I'm going to construct a USB packet to get position. USB subsystem, he's sitting over here. He gets that packet and he goes like, oh, okay, I'll like send that over to the hardware. So this guy gets kind of like piped over here. And then he says like, but when I'm done, I need to like tell the mouse the response. So this guy has to get piped up back here. And so what we want to do is like, along with this like packet request, we also want to send in like a response handle, someone who he can update to get the response back. And so like, this is just a thing that's going to happen one time. He's going to send him the answer once. And so that's where we like, right now we're kind of implementing this with like an infinitely length queue that will only have one thing in it. And that's kind of like silly when we could just pre-allocate and send it back. Feel like a mouse is the perfect use case for multiple services to receive updates about the mouse driver. Yeah, I was thinking about that a little bit. Like, I think that in Linux, I think there's like dev input, and I think that like multiple processes could each bind to these inputs, and I think that in that case you would like have to multicast out. But I was thinking about that a little bit. But then I was thinking, like, do I care at this point in my operating system for multiple users to have different independent updates? And, like, probably not. I think that what makes more sense right now is to have, like, one single cursor that multiple people can pull into, can, like, look at the latest value from it. But I do see the value as well in, like, multiple people seeing events instead of latest update. We're just not there yet. We haven't found a use case for it yet. Okay, so let's just look at our utility section and see if we have like anything that resembles a one-shot feature. No. So we'll just say like we'll make a new one, source util one-shot. That seems pretty reasonable. And I guess the async channel probably resembles this in some way. So being the lazy ass that I am, I'm just going to copy paste this. And so the only thing that we have here is this guy's implemented as, he's got two ends, right? He's got data, and then he has receiver, and sender. These guys both kind of point at the same data, and this guy is like waiting for data on one side, and this guy's sending data on the other. So what we had for our like channel implementation was we had like a queue of data, and this guy's only ever popping off this side, the reader, and this guy's only ever submitting to this side, and these guys are like mutex locked. Probably what makes more sense here is we have like an option T who says you can when you send to me, you like set me. The sender, I wonder if it makes sense to call him a sender here. The nomenclature I've seen in other languages is like promise future. So one guy says like, I promise to give you a value at some point, and the other guy just like waits for that to happen. So I kind of like that. I think that like the Rust ecosystem, I think uses like still uses the channel nomenclature, I think. Let's see. First of all, let's make sure that nomenclature is like a word I'm allowed to say. Is that right? Am I saying system of names? Yeah, that is what I'm trying to say. And then let's look at the futures. Right, that I am not using, but is like what everybody has agreed is the thing to say. Doesn't Rust standard library call it a one-shot channel? Does it have one-shot in the Rust standard library? I thought that was like an external implementation thing. I think I've seen futures feature one-shot. Yeah, this is what I've seen. And so they do call it senders and receivers still. Yeah, I guess fine. I'll leave the names of sender and receiver. I guess it seems reasonable to match what everybody else is doing. Should the inside of him be mutex? Like, do we still need like a mutex protected thing? Probably. I think that seems reasonable. A shared reference to a mutex protected guy. That makes sense. Clone is still valid. Send. I guess if we're using the names of like sender and receiver, having like our thing called send makes sense. But now instead of this being like a pushback on the queue, we'll just say inner equals some val. And that we have to first make sure that we can't overwrite the value if it exists. So we'll just say If some, if what? Inner, first of all, this isn't a queue, this is a value. If inner val is sum, we return an error, so this will return a, some like val already set error probably. And we'll just say pub struct val already set and derive debug on him so that he can be logged. And so if this is something, we say return val already set. Otherwise, we set it. And we still need to do this like waker thing where, so the future, the guy who's waiting, he's gonna like send back a way to say like, hey, wake me up, please. And we just have to wake him up if he's already done that. The rest of this stuff, instead of popping off the front, we'll just say if let sum value is equal to guard q val. We return poll ready with the value, else we return poll pending. This waker thing, by the way, is like a good example of when we would want to use the other version of this class that's like a continuously updating thing. Because then instead of like locking the mutex and setting the value, he could just like send it over and say like, use this waker now. This is the latest and greatest. Otherwise, most of this seems reasonable. This guy is no longer Q, he's a value, and he's going to start with option none. And I think the rest of this is right. So we go into the util module, and we just say pub mod Oneshot. And look for errors. So this guy needs to say he's okay at the end. Guard doesn't make sense because I spelled it wrong. Does your implementation make the one-shot reusable once the receiver receives? Like, is it a regular channel with one slot? No, I think that probably actually the sender... Actually, I kind of want him to consume himself. I kind of want to only be able to be set once. And he shouldn't be clonable, actually, I guess. We can only set him one time. And I guess with this, we actually couldn't error out, because if this consumes ourselves, we know that the only time we're set is if we consumed ourselves. Which makes this easier. So here we can just say assert inner dot is none, or inner val is none. Good catch, good catch, good catch. And then this guy can go away. No Q on mutex guard, so oops, just guard val cannot move out of, so we could probably do a we could probably extract the value. So we'll say core mem take. We'll replace it with a none. Oh yeah, gifted sub. Thank you, whoever gifted. Very nice of you. And otherwise, it looks like it's compiling. We just need to start cleaning up errors now. Yeah, okay. And so where did I want to use this again? I wanted to use this in the USB mouse. Here, instead of somewhere, here, we are using an async channel. And instead, I just wanted to make this a one-shot channel. So here, we'll just replace this with one-shot. And in the USB service, we're going to replace that with a one-shot. Okay. Oops, I maybe went a little too crazy there. And replace it everywhere. No, this seems right. Oh, it's because here I need, sorry, I did go overboard. So we'll just call this one-shot sender. One-shot sender. And I think that's pretty correct. Here, we don't like that the USB TX is a sender, so we'll say one-shot sender here, which means that this guy needs to be a one-shot sender. And in main, when we construct this guy, we need this guy to return a one-shot sender as well, which means here we'll say use this guy as one-shot sender. We'll call this one-shot receiver. Probably don't need that. Well, we'll see what happens. So now packet TX. These guys need to be one-shot receivers and one-shot senders. So we'll see receiver as one-shot receiver. And I think we're almost there. Now we just need this guy to be one-shot. This doesn't seem right. I think I fucked up. I think I'm changing the wrong type. Because this guy... Aha! Yeah. I'm fucking up. I changed too much. It's that the USB packet request, this guy is the only one-shot in here. There we go. So this guy, he takes a one-shot sender as one-shot sender. Okay. I think that's right. And here I also went overboard. We're close. One shot. Okay. He doesn't like a missing comma here. And he doesn't like the unused import. Okay, does that compile? Yep, and if I run this, do we still get the mouse position updates that we want? It's still working, so it looks like that replacing of the channel there with a one-shot did in fact work out. So we are chilling there. I guess probably just for completeness, it makes sense to just write a quick unit test for this. So we'll use super everything, use everything from the parent, and we'll use our testing infrastructure. We'll create a test. And I guess it's like, test only... Oh, I guess there's like, I was going to say I want to test that it's only settable once, but the API kind of like enforces that. So we'll just test submission, I guess. And so what, we have like a channel, which is a channel. We want to make sure that if we try to pull the thing initially, that it's not set. So we'll say create future, I think it's pull immediate. We check if this guy does something. Is this right? This guy returns an option. So we'll say let val is equal to this, and we'll say assert that the first thing we get is none. Then we send a thing. So I guess we just like tx.send for, and we pull again, and we say assert equal value to sum for. Okay. It's a pretty straightforward test. I think that that's all we need to do. Gotta love the Rust type system. Yeah, I like it when the API makes it so that I literally can't fuck up. I've messed up because I forgot to wait here. And otherwise, bing, bang, boom. Easy. Easy. Okay. So that was a nice, clean little chunk of work. Let's just make sure that nothing we did in there was like fucking stupid. So in the USB thing, we say that the packet request now takes a one-shot sender. We have to add the one-shot thing itself. And actually, we completely forgot to add the mouse driver before, so that's a problem. I guess we'll just add it now. We're gonna fold all this down later anyways, so, and like reorder to make it make sense. So we'll just say here, git commit -m checkpoint Oneshot channel for mouse. Okay, so that was pretty straightforward. I'm just gonna give this guy a quick once over to make sure I didn't miss anything. So he has an inner thing, option, waker. He sends to him, and by sending to him, he locks the mutex around the inner type. He sets the value, and then he wakes the waker. Great. In the poll, we try to lock the mutex. If the mutex is not ready, like not lockable, we return poll pending. That's fine. We set the waker. I guess we could do this down here. It doesn't matter, but it's fine. And otherwise, we return the value. Cool. Cool. I guess, is this purely for your learning enjoyment, or would you accept PRs for it? It's a good question. I think I probably wouldn't accept a pull request. Probably. Because, like, in my mind, the goal here is, for me to understand how things work better, doing them is like kind of the best way. And so probably like I want to make sure that I've like done everything to make sure that like I understand it, because that's kind of the goal. But I mean, there's probably cases where like if there's a bug that I didn't notice and somebody filed a PR for it, like maybe I would accept that. It's not like maybe, I don't know. I think it depends, right? Like if somebody was like, here is a like completely from scratch written like display driver or something, I probably wouldn't accept that because I would want to do it. But if someone was like, hey, this feature you wrote's like fucking broken and here's why, like maybe I would accept that. I think it depends. Okay. So that's the Oneshot thing kind of tied up. Oh, I wanted to check. Okay, so if I try to receive multiple times, the second one will just be like hung forever. So probably we need to make sure that like the second attempt fails. And so how do we do that? Right now we're like extracting the value, but maybe we should flag somehow that like we've been set. And like you kind of have that flagged by the option, except that when you finish this, you like take that value 8. So probably you want like a bool in here that's like has like is set. We start with that as false. And then we just say here, when we try to receive, we should fail if it's been set. Maybe we would just assert here. Here, we'll do like a result. T already received error. And the reason that I don't want to like, I'm trying to think of if I could do this with the type system instead of a runtime error. But the problem is that like, if I like take a feature, if I say like, hey, I would like to receive this value, it's not like guaranteed to block forever. So like calling this guy multiple times is sane, because like if I like call this and then I drop the feature before it's resolved, I didn't actually like get the value out yet, you know? And so here we can say that we have a error type that's struct already received. Derive debug on him. And then here, I guess our output would be a I guess here we'll just if We'll do it in the future. The future will return this result as well. And then we'll check here. We'll say if guard.isSet and guard val is none, this is an error. So here we'll say ready error already received. I think that's right. And then here we'll say okay. Which means in the mouse, we actually need to, we'll just say expect data receive. We'll say that this is like a programmer error, so an assertion, and we'll say received, tried to receive same data twice. I think that's a reasonable compile time error. We'll make this like error type public because he's bitching about it. And here in our tests, we'll just make sure that calling him a second time returns an error. So we'll just say assert val is error. Oh, I guess we can't do that. We have to do assert equal val some error already received. I think it's, how did I spell this? I spelled it all the way out. Received. RECEIVD, I think. I before E except after C, and all the other times when it's fucking wrong. And then here we probably need to derive partial EQ and EQ for this to work. Part of a test. So receive doesn't consume the receiver. Yeah, unfortunately not. Because, like, even in this test, we see this case, like, we can see how this would fail, right? We could say, like, let future is equal to rxert receive, right? And in this case, if we then just, like, dropped the future, we would, like, then lose the ability to receive the value. And I don't think that's really fair. I guess the receiver that we returned could be a future itself. But I think that futures don't get consumed when they're polled. So I think it's just easier this way. Maybe there is some way, but it's not like jumping out of me, so I figure I'll just do it this way. Okay, so he doesn't like that actually. So this is on line, oh, it doesn't actually say the line. That's so fucking annoying. I thought it did. Oh, it's because I'm running assert EQ. These should be, oopsies, test true, test EQ. Because when things assert, then we like kind of like lose out on, like we don't run all of the other tests. So we use this like result type to flag that a test failed instead. Which makes our lives a little easier sometimes. What doesn't this like? He like already received. He doesn't like this, probably. It's weird that it's not resolving the type well. But it is what it is. Is what it is. Okay, yeah, so he doesn't like that the second time I pulled this, I was supposed to get an error saying that I've already received it, but instead I got none. Which is odd. So that means that this returned pending. Because here I just didn't set that boolean. Oops. Oops, oops, oops. There we go. Easy peasy. Okay. Cargo format. Check that the Clippy is not returning any errors. Looks good. Test still pass. And so we'll just commit here. Safety check for Oneshot. Cool. I think that ends that story. Okay. So next up on the docket, I wanted to look at kind of like the other version of this, which is a always updating version. So that looks like we're doing 3050 and we're saying continuously updating value. And so I guess like maybe it makes more sense to stub out where I wanted to use that first. And then I can like kind of figure out what that API is going to look like. I looked at the Tokyo implementation. It looks like being a receive consume. The receiver is pretty complicated. It involves mem forgetting the receiver and manually deallocating when it's done, so it can't be dropped. Oof. API wise though, maybe that makes sense. Tokyo Oneshot. So here they have a receiver, and on their receiver they have try receive, blocking receive, who does. Oh, I see. So they either have. This guy's like not even async, which is kind of odd. Right, that's kind of like the blocking receive kind of makes sense. If you have a non-async version, then it's easy to do that, but it's weird. I would think that they should have a async receiver that implements await. Maybe they do have some sort of trait. Yeah, they do have it. Ah, so they have a future. I am in Tokyo Sync. That's a good point. Tokyo Sync Oneshot. Oh, weird. It looks like they only have the Oneshot version. They do have a future implementation for it, which is also kind of weird, though. I think I saw that somewhere. Where did I see that? Here. So they do implement a future for it. But it... I guess maybe the future, like, converting to a future consumes it enough that it's fine. I don't know. I'm not too worried about it. Not too worried about it. Okay. Sorry, so we wanted to okay, so part of what I was thinking was right now we have like this mouse that's like lazily constructed. So when in our like demo function, we create this like section that like waits for USB devices to be like discovered. And we right now assume that the only USB device that could be discovered is a mouse. That's like clearly wrong, but we'll ignore that for now. And then we like set up this mouse service. And what we do right now is we like submit this like queue for mouse position updates that will be forwarded to the game. And what I was thinking would be kind of nice is if instead of like the game class, like knowing that he has a queue of things that he has to service, what kind of makes sense, I think, is if my kernel has like a cursor object on him. So here, instead of like this mouse guy, he should have like a cursor. And the idea is the game would take in this cursor by reference, and maybe he would be able to like just pull the position from the cursor. So if we had like struct cursor, we would have a like function that's just like get position. Let me think about this. Is that what I wanted? So he would return like an F32, F32, coordinates in normalized space. And I guess what I actually kind of wanted was a way to like check if the position changed. That's what I was thinking initially. But I think maybe just a raw get position would be good enough. Let me look at the game class and see. So what we were doing before is we were checking if the mouse moved. But I guess, yeah, what we would do instead here is we would just check. Yeah, we do want to check if the mouse has moved, which means that like we want like some sort of like async function that's like position, like wait movement or something, who would return the latest position after. Yeah, that makes sense. So inside him, he would have this like thing that we're going to implement. Okay. So here we want to pull in the cursor. So we'll just say somewhere mod cursor. And somewhere else we need to use cursor. Our cursor class needs to be public, struct, I guess, and these need to be public functions. This guy needs to take himself, and they need to say that they're unimplemented for now. And I guess we also need a move cursor. Is that what I want? Probably. We'll figure it out. We'll say relative movement is a F32, F32. Okay, so now when we initialize our kernel, we would just say let cursor is equal to cursor new, which means that this guy has to have a function new on him that returns a cursor. And this guy takes the cursor in. Okay. That seems reasonable. And so inside, we're gonna want our like utility class that's like, what do we want to call this guy? Like updated value or something. I don't know. And he's gonna say his you know what? I don't think this is actually making sense for this to be a like generic type. I was gonna say that the cursor kind of is an updated value, but I guess this guy's gonna take in movements. And it's probably okay for his abstraction to be a bunch of movements. So he's gonna have like movements is a reader receiver of position updates. And he's gonna store that. Like this receiver F32, F32. Oh, that's why I wanted the value. Right. Sorry. Okay, so he's got a position, right? But this position should be a like updated value, something that he can like propagate to other people. So let's figure out what that looks like. So he's gonna have like some sort of service function that takes himself in by mutable reference. And this is an async function. And he's gonna like wait for updates from the mouse. So he's gonna be in a loop, and he's gonna be like, let movement is equal to self movements await, or receive await. Let's use the receiver now so that we can like, how do I say this? Get compilers errors working correctly. So we'll use create async channel receiver. Here we'll say we need to have a way to get the sender as well. So we'll say tx is a sender of this. And that means that the movements aren't actually passed in here. We'll like send out these guys. So we'll say let tx rx is equal to async channel. We would include that by self, and we say this is async channel. Okay, so then we pass these guys in here. So rxtx, and we'll make a function here that's like get updater. And the idea is here, like if you had like two mice, maybe you would both update your positions, and you would just fight each other for the cursor position. That doesn't seem crazy. So these guys get a sender of F32, F32, which means that we just clone the writer. And the idea is that maybe the mouse class, when it's constructed, he asks the cursor for the updater, and then he starts sending it. So here he says, I'm going to wait for the thing to move. And I guess we'll call this get movement writer. And everyone else maybe gets a movement reader. Get position reader. Aha! Yeah. And this is where that updated, like the continuously updated value thing makes sense. We have this like thing that could be updated externally, and we want to like keep track of that. So we'll call that like updated value, hold value. Yeah, well, I don't know. We'll say updated value. Fuck it. And I don't like these like F32 tuples, so we'll probably say something more like movement X and Y, as well as position X and Y, which technically are the same but semantically different. So this guy will be movements, right? The movement writer is written by movements, but the position is an updated value of position. And I guess these guys, the inputs are going to be public. I don't really care about making like little getters and setters for them. Cool. So now we do need to make this like update val thing. Which means that in our utils, we need to pub mod updated val, which means we need to make that file, which is updated val rs. We need a comma here. And here we just need to make a pub struct updated val for now. He doesn't like this for some reason. Why not? He's saying a similar path exists. Create util updated val. Oh. Oops. Yep, so this should be util like this. What's he bitching about now? Missing a comma? I don't know how I lost it again. Okay, we're close. This guy needs to take in a t. Okay. Here he doesn't like that, so we'll just say val is a t for now. Okay. So everything compiles. No, because this is unimplemented. And okay. So what's this guy going to look like? He's going to look like similar to the Oneshot, but I think significantly different. But we'll see. Pull this in as a starting point. So we are still going to have like an inner thing that everybody references. That makes sense. Probably inside, he's going to have a list of wakers, right? Like, if we have, like, 4 people looking at the cursor position, they all might be waiting for an update. So this is going to be, like, a vector of wakers instead of waker. And this gets a little tricky because we might have, like, we might want to, like, purge wakers after we wake them as well, but we'll figure that out in a minute. I think that's okay. The value is always set. So I think this is probably what makes sense. Do we want like 2 ends to this? Do we want like senders and receivers? I think it's okay to not have that. I think it's okay to have just the updated val, and when somebody writes to me, I'll write to it and read from it. So maybe this actually is significantly different. We'll start from scratch. Okay. So let's make sure that he has a mutex as well, which means that people can like read and write, whatever. And here we'll say, I think my language server just crashed, which is fucking annoying. So we'll just restart real quick. And I guess we'll just have function write, which takes in the value of t. And an async function wait, which returns a t. And a function read that returns a t. And I guess even though read and write are technically not asynchronous, they don't need to be asynchronous. They kind of do because the mutex that we're using is like an asynchronous mutex. So write's easy. He says let guard is equal to self dot we'll call this inner. And I guess, yeah, that's fine. Inner lock. Oh, wait. And then we say guard dot val equals val. And then we need to figure out what to do with these wakers. So I guess anybody who's waiting, right now, they will have submitted their waker, and then we'll clear them all, I guess. So we'll say let wakers is core mem take self or guard waker. We'll say for waker in wakers, waker wake. Cool. Here we'll say, well, we need to like make a future type, so we'll figure that out in a minute. We'll say this is unimplemented for now. But on the read side, we'll just say lock this guy and return the value. I guess these guys should return references to T. Because like we don't want to force users of this guy to make it copyable. Fuck. He actually doesn't like that. Oops. This vector is coming from the wrong spot, so let's just fix that real quick. And yeah, we can't do that because it's behind a mutex, and that'll be locked. We could return a mutex guard of some sort, but I think probably what makes more sense is just forcing T to be copyable. In our specific case, that's good enough. We might have to come back to this. Okay. So on wait, this is the hard part. I don't know why I just split the window here. We'll say struct waiter, and we will implement future for waiter. We will use core future and all of the associated bullshit. This guy actually needs to have a context as well. And we also need to use pin. Wonderful. Just for this interface to have all the right shit on it. Okay. So the output of this guy is going to be T, which means that this waiter needs to have a T on it, and this guy needs to have a T on it. Because the type is going to be whatever is inside here. On poll, what are we going to have on him? I guess he's also going to take stuff in by reference, so we'll just throw that in there as well. And he's going to have inner. Sure. Which is going to take a reference to a mutex inner T. Which makes sense. Here we say any lifetime, I don't give a fuck. And I guess I want this to be mutable. No, immutable is fine. Okay, so he tries to lock the mutex. So we'll say guard is equal to this. I think we have to pin it. So we have, there's like a core pin macro. It does that for us. Then we can pull the guard. So say like guard is equal to guard pull cx. And if we get something, that's great. Otherwise, we say return pull pending. We are not ready. The mutex is not yet lockable. Wake me up when it is. If we get to this point, though, we want to try to check. I guess. Shit. How do we flag that the thing has changed, right? I guess what we do is on the first call, we just assume that it's pending. And on the next, when we are woken, we have to assume that it's changed. So maybe what we do is we like store. You kind of want to like keep track of when the last time you wrote was. That way you can check when you like asked for a wait and when it finished. So we do have this like, maybe it makes sense to pull in like a reference to the monotonic time. And does this guy live behind an arc? Yeah, he does. Does that make sense? Because then we can say that the written time, or we'll just say like update time is this. And when we construct this guy, we will have to pass in the time. But then here we can say start time is going to be, I think this guy returns usizes for his time. What is it? Yeah, usize. And here we can just say if start time is not equal to guard update time, we are ready. And we say self guard dot, what's the thing called? Val. Otherwise, we need to register ourselves as a waker, or we need to like register a waker. So we'll say guard dot waker dot push cx.waker dot clone, and then we return pull pending. Now, there is a pretty obvious problem here where if the same guy pulls a lot of times before it's been written, this waker list will just grow forever, which is fucking broken. But we'll figure that out later. There, that's what we want. Cannot move out of dereference, so I just hit a little star on this guy. And we need to say that this guy is clonable, copyable. Or else this won't work. Okay. Then here we can just say wait, waiter, dot wait. And we just fill them in. So we say inner is self inner. And the start time is self.update time. Oops, so we need to say let update time is equal to self.inner.lock.wait.update time. Then we pass this in here like this. Cool. Cool. So I think that that's basically it. We just need to make sure that when we update the update time. So we say update time, guard update time is equal to self.time get, or guard time get, I guess. I guess this guy doesn't have to be behind the mutex. So we could just do self.time.get here. Now, what gets tricky here is our time only updates every 4 milliseconds. So using time as the mechanism for us to check the update is like fucking broken. And also, like, why the fuck did I want to do that at all? That's like stupid. Time's like obviously not, oh my god, I'm an idiot. We don't need time at all. We can just say, call this generation. And we can say, every time we update, we just increment the generation. And that simplifies a lot. So we say generation is this. We'll say start generation is the generation. Generation is like this. And we should probably return update all of these generation guys to be U64s instead of U sizes, or else we'll run out. So we'll just kind of huck them in here like this. We'll say start generation is not equal to generation. Easy. Now we don't need time at all, and we're living the dream. And I think it's like pretty likely that this is just fine now. So back to our cursor implementation. So now inside he stores a position, which is an updated val of type position. We'll just make this guy derive copy and clone. I know that copy is like maybe a little disingenuous because it is a 2-byte or like a 2-word thing, but so is a U64, and that's copyable. You know? Okay, so get the position reader. He just says self.pause.clone. This guy needs to implement clone, so we'll say, I think deriving clone for things that have arcs in them doesn't work correctly, if I remember correctly. Oh no, that's fine. I don't know why I saw that have a problem in the past, but it seems okay. And then, so we say for each movement, we say pause.x plus equals movement.x, pause y plus equals movement.y, and we need to clamp this shit, so pause.x is equal to pause.x clamp 0 to 1, right? Because like we're saying our screen space is 0 to 1. Oh, we actually have to pull the value out first and then update it, then put it back in. So say pause.read, I think is what we called it. But it doesn't like that's private, so we'll just, I think we put the pub at the beginning. Yeah, pub function read, pub function async, pub function write. Great. Then we do this, where we update the position. And then we say self.pause, write back the new position. Cool. Cool. I think driving clone might put a where clause on the generic type to also have to be cloned. No, because it's behind a arc. I'm pretty sure. Right, like T is not guaranteed to be clone, but the arc inside is clonable. I just thought that, like, I remember I had to manually write one that arc cloned, and I couldn't figure out why, but whatever. Okay, so this guy needs a way to construct him. So we'll just say we'll take an initial val, and we return a updated val with type T, and we say inner is equal to inner with val is equal to val, generation is equal to 0, and waker is equal to vec new. Then we return arc new mutex new inner. Okay. He doesn't like that for some reason. Oh, because we need to return updated val inner like this. I mean, try to make updated val with a non-clonable type. Oh, I see. Well, I can't. The reason that I have to make them clonable right now is because I want to be able to pull the value out without like consuming it, if that makes sense. So like the thing inside, when I call these like read and wait functions, I want to like get a copy of them out. So I'm not sure if you're saying that I've missed like an API that would let me pull it out without it being a problem, but yeah. Okay. So we'll say let position is an updated val new with an initial value. I guess we'll just make it of pause x 0.5, y 0.5 to be in the middle of the screen. And then we can show this guy here. Okay. I need to write the word await here again. And now probably I just have to update my mouse driver to push updates to this cursor class, and I need to update my game to consume the cursor class. Yeah. So I guess here in our game, we will also use updated val. He's going to change his constructor somewhere to take in a updated val. So we'll call this cursor. Pause is an updated val with type position, which comes from the cursor. So I guess we'll pull in cursor pause as cursor pause. That seems reasonable. And then here we write cursor pause. Okay, so now we have cursor pause here. And this guy is a cursor pause, which is a updated value cursor pause. Wonderful. Now in main, when we construct our game, this guy needs to take self.cursor get pause reader. Cool. And I think we're probably compile again now. Close. Mouse pause rx. So there's like a future pull immediate on this guy. Oh, so this gets kind of weird. How do I say this? So what I did here was I assumed that I could like poll the future and that would tell me if the position updated. But that doesn't actually work here because I can't just like construct this guy and wait. Like if I say wait for something to change, okay, now check if it changed immediately and then give up, that won't work. So we actually might need to do some sort of like future trickery here in order to like wait for a input update. So I guess like what's the thing we're going to do here? We're going to say when input happens, update game state. Otherwise, update game state and sleep. That seems reasonable. So like our input handling would have to come in up here. Okay. Yeah, that makes sense. That makes sense. So wait, just before I get into that stuff though, we'll just disable the mouse stuff for now in the game. and just patch up our mouse driver. So we'll say mouse pause RX no longer exists. The mouse pause writer, or say mouse move TX, is now self cursor get movement writer. Now here we pass in mouse pause TX, but pause is now right. Mouse move TX. Cool, and this guy now needs a center of cursor movement. Okay, which means that this guy needs a pause TX of center cursor movement. And this guy now, just instead of like keeping track of the movement himself, he's just going to say X movement, Y movement is this. And he's going to send a movement of X, X movement, Y, Y movement. That seems about right. And then he doesn't have to keep track of the position in the mouse driver anymore. That's handled by the cursor. All right. I guess let's just make sure that most of this stapling has gone well. So here we'll just say print line or info cursor position is the position. And we'll just derive debug for him for now. And in main, we have to make sure that we're running the cursor service. So here we just say executor.spawn self cursor service. Cool. So that all compiles kind of surprisingly. Let's run, and we should see when I move the mouse, we're getting mouse position updates, but we're not seeing the paddle move as expected. And now we just have to refactor our game a little bit to handle input better. Okay, so here's what we're going to do. We're going to make a function wait for input, and he's going to take in PS2, the like keyboard input as a does this guy need to be mutable? Yep. Mute PS2 keyboard. And the mouse as a updated val cursor pause. I guess probably by reference is fine. And this is an async function. So he's going to run create future select, and he's just going to wait for either PS2 read or mouse dot wait. So we'll say let movement or input is equal to this. What's it bitching about? Cargo check. Oh, because these guys aren't pinned. Okay, so let fut1 is core pin ps2.read. Say fut2 is mouse.wait. And now he say fut1, fut2. There we go. So now we have like an input that will come in, and I guess we say match input. And why do I have to manually pin them? Because the select macro says that he needs them to implement unpin, and these guys don't implement unpin, so we pin them because pinned things do implement unpin, because they're like double pinned or something. I don't really have like a good handle on it. I just know that like sometimes I have to do this. So here I think we have. Oh fuck! I broke my indexer. We'll go back in here, and so I think we need to include future either, I think it's called. And we'll say if we get either left, then we got a keyboard. The select macro doesn't pin them, that's correct. But there's an API reason why it doesn't, and I can't remember what that is at the moment. So we'll say that we got the keyboard input here, I think. Otherwise, we get the mouse input, I think. And can I check the type? So this is a U8, and this is a position. Great. And so then I guess what this guy's going to return is he's going to return an input enum. So we'll say enum input, and we'll just say here he's got a keyboard input that could be U8 or a mouse input that's a cursor pause. And here we'll just say now we return input keyboard input, or input mouse input. Hooray! Now, our update function will take in an input. This guy will take in the input. This guy now pulls in input. And I guess actually, theoretically, so we do like a bunch of things per, like we like update the game at like a certain frame rate. So I guess theoretically you could give a bunch of inputs in between. So maybe you like take in all the inputs that happened and process them in a row. That might make sense. But I guess for now we'll just take one and we'll see what happens. So we'll say match input, and I guess it's correct. This could be like we might get no inputs. So saying option input makes sense, or maybe we say input none. Option input seems fine. So here we say some keyboard down like this. And I guess we just have to apply that to all these guys. That. And then we just also have to handle the idea that it could have been a keyboard pause, which I didn't even know we implemented, but that's fine. Or now we do the mouse inputs here as well. So we could have some input, mouse, pause. And if we see the mouse position move, we just set the position manually to that position. Okay. That's looking pretty reasonable. We just need to make sure that we've propagated these options right. And now comes the part of doing the like actual checking. So we'll say let input is equal to none. My update function, I think, no longer has to be async, which is pretty cool. So this makes sense, and I guess this input, I guess, sits outside the loop. Does it? Yeah, it has to. So initial input is none. We say you can take the input out and shove them into the update loop. And now what we have to do here is instead of sleeping here, we need to sleep and wait for input. So we'll say input fut is equal to wait for input mute self dot keep ps2 or self dot mouse. No field mouse, so I think this is a cursor pause maybe. Nice. Okay. And then when we sleep, we just we sleep or wait for input. So we have to do another select here. So we say while let's think about this. We have like elapsed seconds and delta. Remaining seconds is delta minus elapsed seconds. So instead we should target an end time. So we'll say let end time is equal to we have like the start time, I guess. We already have the end here. Oh, this is the end of the update. We want to find like the target next frame. So we'll say let next frame time is equal to end plus delta, right? That's how much we have till the next frame. And delta is in as F32. So this is be plus delta times self dot monotonic time tick frequency. So that's hold on. Tick frequency is in ticks per second times seconds, which is the delta, is equal to ticks. Perfect. So we can just say that this is as U size. And so now we want to sleep till the next frame time. So we're gonna have to do a loop that like pulls for input and checks for end time. So we'll say while now. So we'll say let now is equal to monotonic time dot get. While now is less than next frame time, we update now before we loop. But now we might pull for input, which I guess goes here. Yeah, that makes sense. So we have remaining seconds is next frame time minus now times that's not good. Yeah, this is in ticks. So I guess we need to actually do all of this in float time instead of tick time, which is kind of weird. So I guess that's end plus. No, this all makes sense. So the sleep time is just going to be next frame time minus now divided by the tick frequency. Hold on, does that make sense? So this is in ticks. This gives us seconds. We want to sleep for seconds. Yeah. You can just continually select for both futures and update input if it resolves it first, or continue to the next frame if the sleep resolves. That's exactly what that's what we're trying to get here. I think if I understand here. So here we sleep for that amount of time, and now we just say select. We'll say create future select input fut sleep fut, and depending on which one of these finishes first, I guess we can say we have either, if the left thing finishes first, we have an input. We have an input and the sleep future. Oh, hold on. This is actually starting to look like something. So we'll calculate the sleep future outside the loop. Yeah. Then we'll like keep a hold of it, and we'll say, next sleep fute or something. You might need to buffer multiple inputs. Yeah, I'm deciding to ignore that for now. But I'm aware. Otherwise, if the thing on the right finishes, then it's time to break. So we don't have to care about anything. We just say, this is a break. Otherwise, the sleep fute. Let's go to the next sleep fute. And I think we're close. We need to pin these things. So core pin. And my input fute will go up here as well. And I'm okay with this guy living in the loop, I guess, just to make things easier. Okay. So I think found input. We need to update the input positions. We found some input, and we say input equals some found input. And we need to update now. So we'll say now is equal to this. Okay. This actually doesn't need to be a loop while condition. We just loop on this, and we don't have to update now anymore. And this has gone away. We don't need this. This all looks right, maybe? Oh. This should be start minus, or end minus start plus delta. Let's think. We need like end plus delta, but we don't want to wait for that much time. We want to wait for like the time minus end minus start. So I'm assuming that there's some sort of canceling out here. Oh yeah, it's start plus delta. Yeah. Which means that we don't need end, probably. Yeah. Cool. I think all of this lines up. We'll see. Let's run and see what the fuck breaks. Okay, so the mouse is moving the paddle now. Sick. And I guess that kind of proves everything we needed to prove. Cool. So I'm pretty happy with that. So the idea here now is we've kind of like I guess simplified maybe is the wrong word. Yeah, but now we have this like concept in the kernel of a cursor. That cursor has like it's continuously updated, and we have a way to like poll for if that future has completed, or like if somebody's updated it. That gets propagated to the game. Our mouse driver looks a lot more reasonable now. It's not holding position, it's just holding movement. And it like we don't have this like weird constructor thing where before we had this like optional mouse in here that got lazy constructed. Now we have like a cursor that's like always there, and when the mouse is constructed, it now just updates the cursor. Yeah, I think the interface between the mouse and the USB driver looks a little bit more sane now. Right? Like the idea of this guy taking in a like one-shot response thing in the mouse driver is like makes a little more sense. Yeah, so pretty happy there. I think that we've got like some good cleanup progress today. I've got a list of other things that I want to handle, specifically interrupt on USB completion is going to be the big one. And then there's like some like polling stuff that we have to handle as well. But yeah, I think overall pretty happy there. Probably we only need like one more cleanup stream, and then we can call this like USB thing and like say we finished the USB thing. But yeah, there's a little more to do. So thanks for watching. If you liked what you saw, I stream most days at around 1 or 2 o'clock Pacific time for 1 or 2 hours. If you missed stream and you want to catch up, there's a YouTube link in the Twitch description. If you're watching on YouTube and you want to say hi on Twitch, there's a Twitch link in the YouTube description. What's next? There's just a little bit more USB cleanup to do, specifically with like interrupts and queuing and stuff. So that's probably what we're going to get onto the next stream, is like specifically handling, what's after USB? Who knows? I haven't got there yet. I'm sure I'll find something that I find interesting. Yeah. All right. Thanks for watching. Catch you on the next one. Bye.